Hi. In this lesson, we're going to use variables and expressions to write rules and formulas for different patterns. Let's talk about it. First, let's remember what these patterns are. The first kind of pattern is an arithmetic sequence. An arithmetic sequence is where patterns of numbers are added and subtracted to the terms to find the next term. And a common difference is what that value is called. So the value that we add or subtract to the terms to get into the next value is called the common difference. We'll explore that more in a minute. Geometric sequences sound like they should be shape patterns, but they're not actually. What we're doing instead is finding patterns where numbers are multiplied or divided to the terms to find the next term. And the common ratio is what that number is. So the number that we multiply or divide to the first number or the second number is called our common ratio. And that tells us what the number after that will be. Well, what is important to know is what terms are. I said terms a lot in those last two slides. A term are the locations of a number in the pattern. So for instance, if I said 7, oops, let me go ahead and change that. If I said, there we go. If I said 7, 10, 13, 16, if these were our patterns, we can see that it's a growing pattern. Well, if I created a table, I would see that 7 is our first term, 10 is our second term, 13 is our third term, 16 is our fourth term, and so on and so forth. So I could continue going on to find different terms in our pattern. A variable expression is the sequence, basically it's the rule or the formula that we can use to represent what's happening in our pattern. So let's practice. I want you to write a variable expression to describe what's happening in the sequence. First, let's go ahead and decide whether it's arithmetic or whether it's geometric. So, from 4 to 8, we'll always start when we're checking. Let's start by using arithmetic. So, from 4 to 8 is plus 4. Well, let's see if that's true throughout the pattern. If I add 4 to everything, 8 plus 4, does that make 12? It does. And does 12 plus 4 make 16? It does. So in this case, it's an arithmetic. It's an arithmetic pattern or sequence. And if it's arithmetic, that means it has a common difference. The same number is being added or subtracted, so that's important to know. A common difference of adding 4. All right, so if we were writing a variable expression, let's use n as the term. So if n is term number 1, what are we doing to each term? So if n is our first term, what are we doing to it to get our next term? Well, we can see in our pattern we added 4. So n plus 4 is the variable expression for this specific arithmetic sequence. Make sure you have this information copied into your math notebook. Okay, well, now let's write a variable expression for this pattern. So I have 1, 5, 25, 125. First, let's determine, is it arithmetic or is it geometric? Well, 1 plus 4 can make 5. Does 5 plus 4 make 25? No, it does not. So it's not arithmetic. It must be geometric, but we want to double check. We want to see if it actually is a geometric pattern. So let's see. So if it's geometric, that means we have to multiply. So 1 times what makes 5? Well, 1 times 5 makes 5. So does the same thing happen to get to 25? 5 times 5, does that make 25? It does. And 25 times 5, does that make 125? It sure does. So this is a geometric pattern. Geometric. Okay, and it's a sequence. That means it's a series of numbers happening over and over again. And in this case, we have a common, so the same number, but it's a ratio. A ratio, remember, a ratio can look like a fraction, like that. And that's why we call it a ratio, because this line right here means divide. So we're either multiplying by a whole number, that we can write as a ratio, or we're dividing. And in this case, we are multiplying. So we're multiplying times 5. All right, well, let's now write our variable expression to show how it's changing. So in terms of n, so if n is our first term, what are we doing to each term to get our next term? Well, we found that we are multiplying by 5. So a lot of people like to write it like this, but that's actually the incorrect way to write that. So we do not want to write it like that. Instead, the algebraically correct way to write it is 5n. Okay, so that would be our variable expression for this particular pattern. That's our formula or our rule. Go ahead, copy this into your notebook. Excellent. All right. Well, for this example, it says 1,101, 0.1. So it's changing pretty fast. And in fact, it's going down. So I don't think that we're going to be subtracting a certain number. I think we're going to be dividing. And if it's dividing, we can tell because it's going really fast. It's jumping big numbers. That means it's geometric, right? Geometric sequence. Which means then that it has to have a common, and what's the last word? That's right, ratio. Ratio tells us we're going to be multiplying or dividing by a number. So in this case, we're going to be dividing by something. So we're going to take the term and we're going to divide it by, how does 1,000 become 100? How does 100 become 1? How does 1 become 0.1? Sometimes the very first set of terms, it's not always easy to determine that. So instead, let's go somewhere within the pattern where it might be easier. So 100 turns into 1. How did that happen? Well, we divided it by, oh, there's a mistake. Actually, there's a mistake in this pattern. I was going to say, all right, the pattern should be 1,110, 1, 0.1. That would be interesting if anyone can figure out why there was a mistake and let me know. That was very interesting. All right, so now let's see. This time it might be a little bit more easy to see where the pattern is. Here again, here we go. Yes, if you guess that we are dividing by 10, then the ratio is actually going to be 1 over 10. So 100 divided by 10 gave me 10. 10 divided by 10 gave me 1. And interestingly enough, 1 divided by 10 gave us 0.1. I wonder what would continue to be. So the common ratio is 1 over 10. All right, well, let's see if we can write our rule. Our rule would be n over 10. There we go. Very good. Go ahead, copy this into your math notebook. Now, for our last example, we're doing this one. Again, is it geometric or arithmetic? 35, 30, 25, 20. It seems to be going down, but it doesn't seem to be going down quickly. So let's check. From 35 to 30 is minus 5. From 30, does the same thing happen here? If I take 5 away from 30, do I get 25? Yes, I do. And that keeps happening. So therefore, it's arithmetic sequence. And the common difference is subtract 5. So therefore, our rule or our formula or variable expression, however you want to say, would be the term, whatever term it is, n minus 5. Excellent. Go ahead and make sure you have this information in your notebook. For the Your Turn page, I'd like for you to do 2 different things with these 4 patterns. I want you, 1, to determine whether the sequence is arithmetic or geometric. And then the second thing is to write what the variable expression is to describe the following sequences. So basically, you're going to take these 4 problems and you're going to do exactly what we just did before. Come tomorrow with any questions you might have and the answers to these, and we'll move forward.